Dear students, in the last lecture we started what is the analytic function and what is the necessary and sufficient condition for a function is to be analytic. Okay, in that we have seen that your function must satisfy two condition. First one is what is all the partial derivative of the function must be continuous and it must satisfy the CR equation. Okay, and we did some problem based on that. Now let us continue the topic and we will continue to solve the problem based on the analytic function. Okay, analytic function. Okay, and we will do the problem based on that. So first problem, example, determine whether the following functions whether the following functions are analytic are analytic. Okay, and if so find their derivative, find their derivatives. Okay, the problem one is what the function is given to you, that is xq minus
Sir,
3xy square
sir,
minus 3xy square and plus 3x
excuse me,
and
sir.
plus I times of what
Sir,
3x square y 3x square y minus yq. Okay, and plus 3y. So just verify the problem. X cube minus 3x square 3xy square plus 3x plus I times of 3x square y minus yq and plus 3y. Okay, the procedure is same. Solution. So let your function is given to you f of z. F of z is the function of xy. So just write down x cube minus 3x y square and plus 3x. Okay, this is first part, and plus I times of 3x square y minus y cube plus 3y. Okay, now comparing this with the standard form. So comparing this with the function f of z equal to what u plus I v, we get u is what x cube minus 3xy square and plus 3x. Okay, and v, you will have v 3x square y minus y cube and plus 3y. Okay, so from this we will get u and v as a function of x and y. Okay, now differentiate u partially with respect to x, so we differentiating u partially with respect to x. Okay, instead of writing dou u by dou x, we write like this. Okay, this is another notation. So differentiate this with respect to x, so this become what 3x square minus 3y square, derivative of x is 1. Okay, and plus 3. Now differentiate this again, differentiating u again with respect to y. So uy is equal to what, x is constant, so this will 0 minus
सर पहले में 3x आएगा ना, अरे 6x आएगा ना
इसमें इसमें
पहला। हाँ सर, उसको डिफरेंशिएट किए ना।
इसको नहीं किया भाई, हमको यू को करना डिफ्रेंशिएट, ठीक है। वी डिफ्रेंशिएटिंग वी विथ रिस्पेक्ट टू वाई, सो इफ यू डिफ्रेंशिएटिंग विथ रिस्पेक्ट टू वाई, सो एक्स विल बी कांस्टेंट ना, सो
लेकिन ऊपर यू जो यू एक्स किया तो उसको एक्स से डिफरेंशिएट किया ना।
यू को एक्स से किया, ठीक है। अभी फिर
हाँ,
से यू को अभी वाई से करना है।
तो सर यू को एक्स से करेंगे तो ये एक्स स्क्वायर है जो उसका थ्री
एक्स,
एक्स।
देखिए भाई अब समझ नहीं रहे हो।
हाँ सर, हाँ
देखिए,
सर, समझ गया, वो वी को
ओके,
मैं देख रहा हूँ सर।
नहीं वी मत देखो, यू देखो,
हाँ ठीक है
ठीक
सर।
है। वी डिफरेंशिएटिंग u with respect to y, so x will be constant, so this will be 0 माइनस, अब y से करें तो 3 2 जा 6 हो जाएगा, दिस विल व्हाट 6 एक्स वाई एंड प्लस this will 0, okay, so you can write this as a minus 6x y, okay. Now also we differentiating v with respect to x. Now in this time we differentiating v with respect to x, so y will be constant, so this become what 6x, okay, 6x y, and minus this will 0, we differentiating with respect to x, so y will be 0, and plus this is also 0, so this become what only what 6x y, okay. Now we differentiating v partially with respect to y, so this is equal to what, this is equal to y. We differentiating v partially with respect to y, so x will be constant, so this is what 3x square, 3x square, derivative of y is 1, okay, and minus 3 y square, derivative of y cube is 3y square, and plus 3, getting, and plus 3, so therefore we can write here ux is equal to what, ux we found 3x square minus 3y square and plus 3, but which is equal to what, vy, which is equal to vy, and uy is equal to what, uy is negative of 6xy, which is equal to what, negative x 6xy is what, 6xy is vx, okay, so negative vx, okay, so therefore we can write ux equal to vy, and and uy equal to negative of vx, okay. Since we can here we can write, since all the partial derivatives are continuous, since all the partial derivative, all the partial derivatives are continuous, all partial derivative are continuous, why this, so why all partial derivative are continuous, because these are the polynomial function, so polynomial function must be continuous, okay. Since all the partial derivative are continuous, and CR equations are satisfied. CR equation means what? Cauchy-Riemann equation. CR equations are satisfied. Therefore, we can say that the function f of z is analytic. F of z is analytic. Why this so? By necessary and sufficient condition, we can say that the function is analytic. And what is the necessary and sufficient condition for a function is to be analytic? First condition is what? The all partial derivative of the function must be continuous and it satisfies the CR equation. So both conditions are satisfied by the function f of z. So we can say that function f of z is analytic function. Okay, f of z is analytic function. Okay, so this is our first part. So our problem says what? Determine whether the following functions are analytic. Okay, this part is completed. And if so, matlab ki what? If function is analytic, then find their derivative. Okay, now our job is what? To find the derivative of that function. Therefore function f of z can be differentiated can be differentiated as usual manner. Okay, therefore function f of z can be differentiated as usual manner. Now find the derivative of that function. Let us move to the next page and write down the function once again. Since f of z is what? F of z is x cube minus 3xy minus 3xy square. Okay, and plus 3x and plus I times of 3x square y minus y cube and plus 3y. Okay, these functions you have. Now find out derivative. We find derivative with respect to x. Okay, just find out derivative of this function. Just find out. So what will be the derivative of this function with respect to x? So 3x square and minus what? 3y square. Okay, 3y square and plus 3 and plus I times of what? 3 to the 6 6xy and this will 0, only this. So this is your derivative of that function. Getting? Number 2, problem number 2. Your function is given, that is what? E raised to x into cos y minus I sin y. Okay, e raised to x cos y minus I sin y. This function is given to you. So let us find out the function. Find out whether the function is analytic or not. Okay. So let your function f of z is equal to what? E raised to x into cos y minus I sin y. Okay. So just multiply I inside the bracket. So this become e raised to x cos y minus e raised to x. Here write down I times of e raised to x into sin y. Okay. Now comparing this function with standard form. So comparing this with standard form, that is what? F of z equal to u plus I v, where u and v are functions of x and y. We get u is equal to what? U equal to e raised to x cos y and v equal to negative of e raised to x sin y. Okay, now again we will do the same job. We differentiating u partially with respect to x, so u dou u by dou x. So in this time y is constant, so derivative of e raised to x is what? E raised to x cos y as it is. Okay, cos y as it is. Now differentiating u partially with respect to y, so dou u by dou y. So this equal to e raised to x is in this time constant, and derivative of cos is what? Minus sin y. Okay, also we differentiating v partially with respect to x, so dou v by dou x is equal to what? So we differentiating v partially with respect to x, so sin y is constant, so derivative of e raised to x is same as e raised to x and minus n we put as it is, and Sin y is constant. Okay, sin y is constant. And differentiate v partially with respect to y. So we differentiating v partially with respect to y. So x will be constant. E raised to x will be constant. So minus e raised to x as it is. Derivative of sine is what? Derivative of sine is cos y. Okay. Derivative of sine is cos y. Now see here. This is equal to what? First dou u by dou x, and which is equal to what? Which is equal to e raised to x cos y. Okay. But which is equal to what? Which is not equal to dou v by dou y. Why this so? Because here negative sign is there, na? Here negative sign is there. So this dou u by dou x is not equal to what? Dou v by dou y. Why this so? But our Cauchy-Riemann equation says that dou u by dou x must equal to what? Dou v by dou y. Okay. Therefore, and dou u by dou y. And what is the dou u by dou y? Dou u by dou y is what? Negative of e raised to x sine y. But this is equal to what? E raised to x sine y. E raised to x sine y is same as what? Dou v by dou x. Okay. Dou v by dou x. Okay. So which is also not equal to what? Negative of what? Negative of dou v by dou x. Therefore here we can say that since all partial derivatives are continuous, all partial derivatives are continuous, but CR equations are not satisfied. CR equations are not satisfied. Therefore we can say that by necessary and sufficient condition of a function is to be analytic is that it must satisfy CR equation and all partial derivative must be continuous. But one of the condition here does not satisfy. Therefore we can say that f of z is not analytic function. Okay. Therefore f of z is not analytic function, hence it cannot be differentiable. Okay. Hence it cannot be differentiable. Now let us move to the next and important type of problem. That is the another type of problem. Okay. Next example. So that the function defined by f of z equal to xy into y minus ix and divide by x square plus y square when condition is what? Z is not equal to 0, and another condition this is equal to 0 when z equal to what? 0. Okay. This function is defined like this. So that the function is not analytic at the origin, at the origin, although al, although Cauchy Riemann equation, Cauchy Riemann, although Cauchy Riemann equations are satisfied. Okay. Uh, Here, what have to do? We have to show that the function is what? Function is not analytic at the origin, okay, but it satisfies the CR equation. That is what Cauchy-Riemann equation. So for this, what have to do? We have to first find all the partial derivative and check whether all the partial derivative are exist and it is continuous or not. Then after that, we will show whether the function satisfy the CR equation or not. Okay. Now let us see how to show this function is analytic or not. Okay. So what is given to you? Your function is given. Just write down given function f of z equal to what? xy into y minus ix and divide by what? X square plus y square. This function is given to you. And what have to do? We just separate it. Okay. Just multiply this. So we multiplying this inside. So this become what? Ax y square. Okay. X y square and minus I times of, so here become x square and y, okay, and divide by what? Your denominator is x square plus y square, okay. Now we will separate this, so we will have x y square by x square plus y square, okay, minus I times of x square y by x square plus y square, okay. Now comparing this function with standard form, so we just comparing this with our function f of z is equal to what? U plus I v. And what is u and v over here? Where u and v both are functions of x and y. So just write down where u and v both are functions of x and y. Okay, we get if we comparing this given function with your standard form, you get u is the what? Functions of x y. Just write down u y, and this is equal to first term, this is x y square and divide by x square plus y square, okay. And v is also functions of x y, and this is equal to what? Negative of x square y divide by x square plus y square, okay. Now our job is what? Our job is to find out what? Partial derivative at origin. So let us see how to find partial derivative of the function at origin, okay. So let us move to the next place, then we will find partial derivative at the origin. So therefore dou u by dou x, okay, we find partial derivative of this function at the origin, means what? 0 0, okay, and this is equal to limit h tending to 0 u of h 0 minus u of 0 0 and divide by h. This is the formula for partial derivative of the function u, okay. So just write down this is equal to limit h tending to 0, okay. Now u is what? U become functions of h, here y is 0, okay. So here x equal to h and y equal to 0. So just replacing this, just replacing that variable in this function. So here x will be what? X is h. Just write down. So this is x is h and y is what? Y square, that is 0. So here h square and plus 0 square and minus. So if you putting x equal to 0 and y equal to 0 in this function, so this become whole thing will be what? 0. So 0, getting, and divide by what? Divide by your h denominator term. Now here 0 multiply in this function, so this becomes 0 and minus 0, that is 0. So this is what? 0 by h, so that the whole thing will be what? 0. So just write down 0, getting. Now we will find similarly we will find partial derivative of u with respect to y at the point 0 0, means you have to find a partial derivative at origin. Your formula is what? In this time we differentiating partially with respect to y. So here limit, your formula become limit k tending to 0, k tending to 0, u of, in this time x will be 0 and y will be k, okay, and minus u of 0 0 and divide by k. Okay, this is the formula, you must remember this formula. Okay, and just write down this equal to limit k tending to 0. Okay, here u become what? Functions of 0 and k. Here x is 0 and y is k. Just replace that value in the function here. X is what? 0, y is k. So we have x is 0, y is k, that is k square, and divide by x is 0 and plus y is what? K, that is this become k square. Okay, here. Now putting x equal to 0 and y equal to 0, so this become whole thing will be 0. So here will be whole thing 0 and divide by k. Okay, here 0 multiplied in this function, so this become what? 0. So 0 minus 0 is 0 and divide by 0, so whole thing will be what? 0. Okay, whole thing will be 0. Now also we will find partial derivative of v with respect to x at origin, that is 0 0. So we will have the formula limit h tending to 0, okay, and v of h and y become 0 minus v of 0 0 and divide by h, like first time. Okay, like a first formula. So just write down limit h tending to 0. Now come to the your function. Here h is what? Here h is sorry, here x is h, okay, and y is 0. So this is what? Negative of h square and y is 0. Just write down. So this become h square and plus 0 and minus, we putting x equal to 0, y equal to 0 in the given function, so this become what? 0 and divide by h. Okay, here 0 multiply this function, so your whole function becomes 0. So 0 minus 0, that is 0, and 0 divided by h, the whole thing will be what? 0. Getting? Now similarly you can find partial derivative of v with respect to what? With respect to y at origin 0 0. So this equal to, you have the formula for this. So in this time what? We differentiating partially with respect to y. So in this time we write limit k tending to 0, v of 0 comma k minus v of 0 0 and divide by what? K. Getting? Divide by k. So here I am writing, so limit k tending to 0. So just replace your function by 0 and k. Here x is 0 and y is k. Okay, here x is 0, so y is k. So this become minus x is 0, just write down 0. Okay, and y is k. X is 0, that is 0 square is 0, and y is k. Just write down. This is into k, and divide by what? uh, X is 0, this becomes 0, and plus k square, and putting here x equal to 0, y equal to 0 in the given function, so this become what? So 0 and divide by k. Okay, here 0 multiply, so this become what? 0 minus 0, that is 0, and 0 divided by what? K, that is what? 0. Okay, now come to our problem. So your problem says that what? So that the function is not analytic at the origin, although Cauchy-Riemann equations are satisfied. Let us check whether the function satisfy Cauchy-Riemann equation or not. Okay. So just name this what? Just name this. This is equation number 1. This is 2, and this is 3, and this is 4. Okay. So from 1, from 1 and 4 say that what? Dou u by dou x equal to what? Dou v by dou y. Is this equal? Yes, because what? These values are 0 and 0. So both are equal. So from 1 and 4, 1 and 4 we can say that dou u by dou x equal to what? Dou v by dou y. And from 2 and 3 says that 2 and 3 dou u by dou y is same as what? Dou v by dou x. Okay, if you multiply negative signs, so there will be no change because here 0. Okay, so from this you can say that dou dou u by dou y equal to what? Negative times of dou v by dou x. Okay, therefore we can say that all partial derivative are exist and it is continuous. Okay, therefore we can say that all partial derivatives are exist and it is continuous at origin. Okay, therefore we can say that CR equation satisfy continuous at the origin, and also CR equations are satisfied. CR equations are satisfied at the origin. Okay, at the origin. Therefore the function is analytic at the origin. Okay, therefore f of z is analytic at origin. Okay, now this is only first part. This is your only first part. What I have to show that? You have to show the function is not analytic. Okay, you have to show function is not analytic. Now let us check. The function is analytic at the origin. Now is the function is analytic at another point? Just check. Okay, now consider your function, consider your main function, consider function f of z. F of z is equal to what is the main function? Your just write down the main function xy. Main function is what? Xy into xy into y minus ix into y minus ix, and this is divided by what? X square plus
y square.
y square. Okay, since we know that since we know that differentiability formula f dash of 0 is equal to what? Limit z tending to 0 f of z minus f of 0 and divide by what? Z minus 0. This is your formula for differentiability of the function. Okay, so therefore we write here f dash of 0 and this is equal to what? Limit z tending to 0. F of z, your f of z is this function. Just write down x y into y minus I x and minus. Uh, we putting here z equal to 0 in this function, so this become whole thing will be 0. Okay, and divide by, you divide by denominator, that is x square plus y square, and the whole divide by what? Whole divide by z. But z is what? Z is your x plus iy. Okay, this is z na. Since here just write down, since z equal to x plus iy. Okay, so just write down in simplified form. So this is what? Limit z tending to 0. We write here this x y into y minus I x and divide by, this denominator comes here, so this become what? X square plus y square and into x plus I y. Okay, x plus I y. Now we will check the limit of the function. Okay, we will check limit
सर
of
टाइम
the
हो गया.
function. Now see here, if I take here common, if I take I common, then what become here? Just I'm taking I common. So limit z tending to 0. So I am taking I as a common. So x y. Okay, x y. So this become what? This become, if I taking x as a common, sorry, I as a common, so this can be written as what? Y upon I, ऐसा लिख सकते हैं, and minus x. Okay, minus minus x. Okay, so what happened here? Just take minus I common. Okay, I'm taking minus I common, so this become minus I and this become what? Plus. Okay, and divide by x square plus y square and in the bracket ax plus iy, ax plus iy. So let us move to the next page, or should I write over here? Just write over here. Okay, so this become what? Limit z tending to 0. Okay, just cross multiply. Just cross multiply. We just rationalize here. So we rationalizing here. We multiplying here I. Okay, we multiply here I, conjugate of I. See here, I am multiplying here. This is what? 1 upon I na. This is 1 upon I, negative sign here. We multiply by conjugate of this, so minus I and minus I. Okay, so if you multiply this, so you will become what? Minus minus goes plus, so this become I simply, and here negative of I square. Okay, but negative I square is what? So this can be written as what? I, and here minus I square is what? Minus 1. So this becomes simply minus minus plus, this becomes simply I. Okay, so here we can write simply, simply here instead of y by I, we simply write here yi. Getting? So negative of x y I. Okay, and yi plus x and divide by what? X square plus y square and divide by x plus iy. So see here, x plus iy, this one and this one cancel. Okay, what is remaining? This term. Just write down in the next page. So let us move to the next page. So therefore we have f dash of 0 and which is equal to limit z tending to 0, and your function is what? Negative of I x y and divide by what? X square plus y square. Okay, now we will check limit, existence of limit. Now we will put what? We will put, or we will check the limit along the path. Okay, so along the path y equal to mx as z tending to 0 and x tending to 0. Okay, so therefore we have f dash of 0, and this is equal to what? Limit x tending to 0. So instead of y we putting here mx, so this become what? Minus I m minus I x minus I x into m x, and divide by what? X square plus y square, that is what? M square and x square. So this become what? Limit x tending to 0 minus I m, and here x square, we taking here x square common, so we'll have 1 plus m square. So x square and x square will cancel, so we will have limit x tending to 0 negative of I m divided by what? 1 plus m square. See here limits depends on the value of m. Okay, here write down, since limit depends upon the value of m. Okay, therefore for different value of m, for different value different values of m, limit will be different. Okay, limit will be different. Limit will be, for different value of m, limit will be different. Therefore we can say that limit of the function is not unique. Therefore limit of f of z is, limit of the function f of z is not unique, is not unique. Okay, लिमिट यूनिक नहीं है. Therefore we can say that f dash of 0 does not exist. F dash of 0 does not exist. Therefore function, the whole function f of z is not differentiable, not, therefore function f of z is not differentiable anywhere except origin, except at the origin, okay. Hence f of z is not analytic function, okay. So this is your complete proof of the problem. I hope you understood. This is a very important problem. आपको
सर
अभी, हाँ
चैट बॉक्स में सर जरा देखो एक क्वेश्चन है, उसका थोड़ा सवाल बताओ.
इसमें चैन में
चैट बॉक्स में.
कहाँ पे है? Equation is not differentiable, so it can be continuous equation. Can you say or not? Okay, इक्वेशन डिफरेंशिएबल नहीं है. देखो, डिफरेंशियबिलिटी इंप्लाइज कंटिन्यूटी. इफ इट इज नॉट डिफरेंशिएबल मतलब नॉट कंटिन्यूअस. समझ में आया जयसवाल शिव कुमार?
यस सर.
हाँ, अगर डिफरेंशिएबल है तो कंटिन्यूअस होगा. ठीक है, और कंटिन्यूअस है तो ये गारंटी नहीं है कि डिफरेंशिएबल होगा. डिफरेंशियबिलिटी क्या है? डिफरेंशियबिलिटी के लिए कंटिन्यूटी क्या है? उसका नेसेसरी कंडीशन है. ठीक है, मतलब कंटिन्यूअस होना नेसेसरी है, लेकिन सफिशिएंट नहीं, सफिशिएंट कंडीशन वो नहीं है. तो फंक्शन अगर डिफरेंशिएबल है तभी वो कंटिन्यूअस होता है, अगर फंक्शन एनालिटिक है तभी वो डिफरेंशिएबल होता है। ठीक है, और डिफरेंशिएबल है तो एनालिटिक होना जरूरी नहीं है। ठीक है, डिफरेंशिएबिलिटी इज ओनली नेसेसरी कंडीशन। गेटिंग?
Yes,
शिव
sir.
कुमार, यू अंडरस्टूड?
Yes, sir.
ओके, ठीक है, एंड वी विल मीट टुडे इन द नेक्स्ट लेक्चर। थैंक यू ऑल ऑफ यू, यू कैन लीव नाउ।